So, we're going to talk about numerical models, algebraic models, graphical models, and that, the wording, I mean, don't worry about whether it's really numerical, math or algebraic. Graphical should be obvious. That means it would be a what? Graph, okay? So, the zero factor property, let me see if I write this. Come here, paper. What are your solutions? 6 and 2. And you're using the zero factor property when you do that. So what did I do? I factored it. It said equal to 0. And in order for that times that to be 0, one or the other has to be 0. So you use the zero factor property all the time. You just didn't bother to call it the zero factor property. Okay? And then problem solving is just what it's always been. Figure out what your problem is, how you're going to go about solving it, and we're not going to worry about graphing failure and hidden behavior today. So, fancy terminology. A mathematical model is a mathematical structure that approximates, you do not need to copy this down, phenomena for the purpose of studying or predicting their behavior. A numerical model is a kind of mathematical model in which numbers or data are analyzed to gain insights into phenomena. Algebraic model uses formulas to relate the variable quantities associated with the phenomena being studied. So in a minute I'm going to give you a table. That's the numerical model. I'm going to make a picture of it. That's the what? Graphical model. Then I'm going to write an equation of it, and that's the algebraic model. Okay? All right, problem solving. A pizza shop sells a rectangular pizza that's 20 by 22 for the same price as its large round pizza that's 24. If both pizzas are the same thickness, which option gives you the most pizza for your money? So what do I want to know? Which one do I want to buy to get the most pizza for my money? That's my problem, right? Okay. So I need to find the area. Why the area? Because we know they're the same thickness. So if I figure out how much area I have, because they're the same thickness, will the bigger area give me more pizza? Okay? How do you find the area of a rectangle? Length times width. How do you find the area of a circle? Pi r squared. So length times width is 440. Pi r squared is 452.4. So which pizza should I buy to get more pizza for my money? The circular pizza. Okay? Again, a graphical model is a visible representation of a numerical model or an algebraic model that gives insight into the relationship between the variable quantities. Okay? The zero, a product of a real number, is a zero if and only if at least one of the factors in the product is zero. And now for the fun. Solve the equation algebraically. Solve the equation algebraically. Alright, so you are more than welcome to write this down. If you want to solve it, you're also more than welcome to just follow along. And I wish I could tell you that it's going to focus sometime here in a moment, but for some particular reason, there's something about this page. There we go. Alright, so what kind of equation am I trying to solve? Quadratic. So I need the solutions to a quadratic equation. What is the best way, or what is the first thing that makes the most sense in order to solve that? Set it equal to 0. So x squared plus 4x minus 8 would equal 0. And then, if I want the easiest way out, I'm going to try to see if that quadratic will do what? Factor. Does it? No, because 2 factor is something we need to multiply to what? Negative 8 and add to 4. Alrighty. So, what is another way you were taught Because quadratics never went away last year. What is another way you were taught to solve a quadratic equation? Quadratic formula. Okay? That's the save all end all. What's another way? Completing the square. What's another way? That's the form of factoring. But slip and slide is something, but you use slip and slide to factor. There's one more. Well, graphing is another way, but it's not an algebraic way. But graphing is another way. That's still a form of factoring, babe. Well, you're going to have a hard time guessing on this one because the real solutions are -2 plus or minus 2 to the square root of 3, and I don't think you'd probably just guess that off the top of your head. How about square root properties? Okay, but why is this not a candidate for square root property? What had to be missing in order for square root property to work? The x term. Remember, this had to be gone. The b had to be missing in order to do square root property. Okay, so I am going to fly through this. I am not trying to teach you this concept. I'm just reviewing you of this concept. The biggest important thing today is I would expect that you should all be able to easily do quadratic formula, okay? So remember to complete the square. I would have done x squared plus 4x plus some number equals the 8 plus that same number. How do we find this magic number? We do what to this? Take half and square. So half of 4 is, and 2 squared is 4. By doing that, we've made this what we call a perfect square trinomial. And all a perfect square trinomial means is it's the same factor times itself. So what multiplies to 4 and adds to 4? 2 and 2. So I can write that as x plus 2 squared. That's a 12. Then we go back to square root property. What do you have to put in front of the square root? Plus or minus. And then we slide that 2 over. So -2 plus or minus 2 square root of 3. And where did 2 square root of 3 come from? Because 12 is 4 times 3. Okay? All right. Graphically, I would never be able to get that answer. I could get an approximate, but I would never be able to get that actual answer. Okay? Let's review quadratic formula. X is equal to -b plus or minus c square root b squared minus 4ac all over 2a. Okay? Y'all have to learn to sing with me. Don't be embarrassed. What's A? What's B? B is 4, and C is -8. So x is equal to -b plus or minus c square root b squared minus 4ac all over 2a. And that, when I clean it up, it's going to become a 48. And then if I simplify 48, it becomes 2 square root of 3. 4 square root of 3, then that reduces. Those are equivalent answers, or just different forms of that answer. Okay? This is not simplified yet. All right? So, we couldn't factor it. We could complete the square. We could do quadratic formula. Now, if I take algebraic out of it, I could graph it, but I would never be able to get this answer from a graph. I could get a decimal approximation, but I would never be able to get an exact solution from a graph, even if I used a graphing calculator. The graphing calculator is not going to tell me -2 plus 2 square root of 3. It's going to say 5.76 or whatever it happens to be. Okay? All right. If I was going to graph this, let's just forget about solving it. Let's just talk about reviewing graphing. I want to graph this. What form do we call this? Standard or vertex? Standard. Remember vertex is y equals a x minus h squared plus k. How can I make this look like that? Find the what? The vertex. How do I find the vertex from standard form? What do I do with standard form to find the vertex? X equals what? What was my first step? Nope, you don't set something to 0 and something else to 0. What? It's b, negative b over 2a. X equals negative b over 2a. So negative 4 over 2 times 1 is negative 2. Plug it back in. Negative 2 squared would be 4 minus 8 minus 8. And that's going to give me negative 12. So where's my vertex at? Negative 2, negative 12. Is this A the same as that A? Are these A's the same A?
No.
Are these A's the same A? So what is A going to be down here? 1. What is H going to be? Negative 2. So X minus negative 2 becomes what? Plus 2. So now if I wanted to graph that by transformation, what does this mean to do? Left 2 and down 12. Left 2 and down 12. So if your teacher taught you to graph by parent points, would you take those 5 parent points and move all of them left 2 and down 12? And here we would have this graph. Yes? Okay. Your teacher may have said, okay, don't worry about parent points. We know the vertex is at negative 2, negative 12. What do we know the y-intercept of this equation is? It's sitting right there in the equation. What's the y-intercept? Negative 8. So if I have a dot at negative 8, do I have another dot over there? Okay? And then they may have asked you to plug in one other number, and if you get something on this side, then there is something else that matches it on the other side. Okay? So that's just a little bit of a review of graphing. Okay? All right. There would be your answers. The reason you would never get pretty answers is because they're irrational. That means they never end and they never repeat. So all you can do is get, what does this mean? About. This is actual. This is the approximate. Okay? All right. Do you remember the many different names? Do you remember your teacher saying you can call them roots, you can call them solutions, you can call them zeros, you can call them x-intercepts? Are they all the same thing? Find the x-intercepts, find the roots, find the solutions, find the zeros, okay? When is the solution to a quadratic equation not an x-intercept? When is the solution to a quadratic equation not an x-intercept? Yes, sir. And so what is it going to look like as a solution that makes you know it's never going to touch the x-axis? All right. So, hang on. Y'all are throwing good words out there. So, parabola is always going to look like that, right? Is there an asymptote in a parabola? No. It has a minimum or a maximum. It has a high point or a low point. It's another word. It doesn't start with A, but it starts with I, when the solutions are imaginary. All right, so remember those I's? When the solutions are imaginary, then they are solutions, but they are not considered x-intercepts. And they're not technically considered zeros because the zeros would be on the x-axis. Okay? So, that's the only time you have to be really careful. All right, now, we learned to graph a whole bunch of things last year. What is this a graph of? a linear equation, right? This is a what? Absolute value equation. This is a parabola, or x squared. What was this one? Square root. And these go together. Exponential, this one's exponential growth, this one's exponential decay. This is where your asymptotes come in. It gets down close to it, but doesn't cross that, all right? Then we talked about inverses. So if I take that exponential and flip it over the line y equals x, my graph is going to look like this, and that is going to be, what's the inverse of exponential? Can anybody remember? Starts with an L. Log. The log. Now, of these graphs on this page, what's the domain? What is the domain? Our real numbers. What is the domain? Our real numbers. What is the domain? Our real numbers. What is the domain? All real numbers greater than or equal to 0. Domain? All real numbers. Oh, sorry. Greater than 0. So, do these two have a restriction on their domain? And when they have a restriction on their domain, enjoy your lunch and remind me where we are when we get back. This is going to be a problem because I can't pause this video.